we will continue a discussion, the clinical chemistry. So I will start about something is called potentiometry. So what is a potentiometry? Is the measurement of the electrical potential between two electrodes. So we have two electrodes, as you can see here. I know that is so bright. So we have here a potentiometer, which is composed of the two electrolytes. Okay, so it's like measurement of the electrical potentials between these two electrodes. One of them is affected by the contact of the ions in the solution, which is called sensing electrode. So we can say measuring electrode, sensing electrode, and we have also the reference electrode. So we can just put in our mind what is the potentiometry. So we have here the potentiometry, which is composed of the reference electrode and the sensing electrode. The reference electrode, it's a stable reference electrode. So here we have something is called the reference electrode, which is like a stable electrode, okay, and the other one with what we called it as a sensing electrode. Okay, so here we have these two things. So we have here a potentiometer, which is composed of the two electrodes, which is known as a reference electrode and the sensing electrode. Here the reference is stable, okay, it's just like reference from its name, and the sensing electrode like measuring this electrical potential that is present in the solution. So that is the electrode that is affected by the ions that is present in the solutions. The factors that is affected the electrical potentials between the reference electrode and the sensing electrode is many things. These are the factors. The first one is the concentration of the ion exchanges. I said not the concentrations of the ions, but I said the concentration of the ion exchanges, how they are changed, okay? And also the ionic strength, the height, the pH, and the sample mixture. So all these factors that is affected how it's the electrical potential that is can be present between the two electrodes. So we have the reference electrodes, sensing measuring electrodes, and we have the multiple factors that is affecting the action potential between these two electrodes. The first one is the concentration of the ionic exchanges. We have also the ionic strength, the pH, the height, and also the sample mixture. So what is a solution? The solution is a mixture that when the sample mixtures alter the relationship between the measured activity and the resulted concentration. So we have actually different method. We have a direct method, which is measure the ion activity and then control the condition with the heat block. For example, like a blood gas analysis. And we have indirect method. First control the conditions and then we measure the activity of the ion. And how we control the condition? We dilute the solution and we fix the ionic strength. Before we just continue, actually, when the sample mixtures alter the relationship between the measured activity and the resulted concentration, we have said that before that one of these factors is the sample mixture. Yes, the sample mixtures is affected this, you know, this solution. So we have two methods actually. We have direct method and we have also indirect method. The direct method, we measure the ionic activity and then we control the condition. We can do the heat condition or something. So the first one, that we measure the ionic activity. So we measure the ionic activity and then we control the condition by the heat block. And one examples of that is the blood gas analysis, and we use the blood gas analysis in like we just diagnose the asthma or the lung diseases. Actually we use the blood gas analysis. So how we do that, how we measure all these things, we just measure the ionic activity, and then we control the conditions. That's why direct. Why direct does mean we measure first. Indirect, no, we control the condition and then we measure the ionic electronegativity. But in the indirect, we just make dilution of the solution or fix the ionic strength. Then we talk about the potentiometric analysis by the pH electrode, or we use something is called the pH electrode. Okay, so it's called potentiometric analysis. Okay, so we have here the pH cable, and then we have something is called electrode head and electrode glass shaft, screen, internal conductor, electrode, inner buffer, pH sensitive glass membrane. So we have here the first things is the pH cable, and then there is electrode head, the electrode glass, okay, shaft, here the screen, here the internal conductor, electrode, which is AgCl, and here we have the inner buffer and the pH sensitive glass membrane, pH sensitive glass membrane. So this is exactly the pH, but the question is here the electrode head, we wanted just to analyze these conditions, and here the glass, and here the screens, and here the internal conductor, and as we can see here that is formed of the AgCl, and here we have the inner buffer, and here the pH sensitive. So we measure here because it's a pH sensitive here. So as you can imagine here the pH electrode, here we can say the glass membrane, here the inner gel membrane, here the pH is more than 7 and here the pH is less than 7. So it's, you know, here acidic, here alkaline. And the electrode that we have to use the measurement is the AgCl electrode. Okay, so the measuring electrode needs to be hydrated. Okay, that's so important to know. Need to be hydrated, immersed into the normal water tap for at least 24 hours before it use. So this what we can say as electrode, you know, the measuring electrode or the sensing electrode should be hydrated. We have to be hydrated for the 24 hours before we use it. Okay, and some manufacturer deliver their electrode already hydrated, like the membrane is kept wet with the KCl solution in a plastic cap. So if it's not hydrated with the KCl, then we have to make it hydrated 24 hours before it used. Okay, but if it's already hydrated with the KCl and put it in a plastic, we'll make sure that it's hydrated, then it's okay, and we have to do nothing. So why we do this electrode, why it's hydrated? To respond quickly to the ionic changes, this is the first one, and to help constant membrane potential. So that's a question that comes to your mind, why we make these hydrated. For two reasons. We make this hydrated because it will increase the sensitivity of measuring the ionic change and the ionic activity, and the other thing that makes this membrane constant. Then we go to the electrochemical sensors measurements. So measure the most critical care analytes like gases, electrolytes, and glucose. That's what's so special about the electrochemical sensors, that they can measure the gases, they can measure the electrolytes, and also they can measure the glucose, and that's what we need actually. Measure then outside, like pre-treatment and the dilution. Okay, I don't understand my line. So it's rapid and non-destructive. We are just talking about what are the so special about the electrochemical sensors. So the first one, that they are measure the most critical analytes like glucose, electrolytes, glucose, and also the gases. Measure them without pre-treatment or dilution. Now I understand. So we can measure them without using the pre-treatment and dilution. Here we can say we have to hydrate it, we have to do something, but in the electrochemical, so we don't have to make a dilution, we don't have to make any pre-treatment. It's rapid, non-destructive because it's no destructive, and it's not affected by the sample turbidity. So if there is a lipid, or if there is RBCs, or there is something, so that is not affected by it. Stimulus measurement of the multiple analytes in the same blood sample, so it can measure also the multiple analyte. So we can just say what is so special about the electrochemical sensors, that they are can measure the most critical analytes like the gases, electrolytes, glucose. Was so important that they can measure multiple analytes in the same time in the same sample. The other thing that is rapid, so rapid and accurate, not destructive, and we can measure these things without using any pre-treatment or dilutions. And the other thing, it's not affected by the turbidity. So if the sample there is full of the lipids, or if there is a hemolysis or something, so it's not affected by that. Accuracy, it's mean how to close to the true value, and that is depends on the valid calibration process. And we just understand, or we just explain that before, what is the calibration, because just pick what is a centrifugation, and then we go to the calibration. The calibration, I just said that we control all the conditions that around the sample, like a temperature, humidity, a pH, all everything that is associated with the samples. And accuracy, how to reach the true value of these samples, and that is depends on the valid calibration process. So the calibrator value assessment is linked to the certified reference material, or canonized reference method, or a consequence provide traceability. Okay. So the calibrator value assessment is linked to the certified reference material, or canonized reference method, or consensus provided traceability. Now we go to something is called the standard deviation. It's reflect the spread of these values from the mean value, like how they are far from the mean value. That's exactly what we call them as a standard deviation, the spread of the values from the mean value. It's a measure of the precision. It's a very scientific method that we use it in the measurement, how accuracy and how precise our our experiment. So there is something is called the coefficient of the variation. Uh, we have also something is called the coefficient of the variations, and this is standard deviations expressed as a percent of the mean. So the coefficient of the variations equals the standard of the deviation divided by the mean multiply 100. So it's a percent. Okay, so it's a percentage. So what is the coefficient variations, or the coefficient of the variations, equal the standard deviation divided by mean multiplied by 100. And then we go to something is called quality control testing. Quality control testing is a control sample that is analyzed multiple times, usually daily, over an extended period of time, weeks to months, that ensure that the test give reproducible results, because we use like a control sample. So this control sample, we analyze it many times, and that is daily, for a weeks, for a month. Why? Because we want to make sure that it will give us a good and accurate results. And that's exactly what is a quality control testing. Quality control testing is to analyze a control sample multiple times, I mean daily, over extended periods of time, weeks to months, to ensure that is give the reproducible results. So I will finish here. Thank you for listening, and I will complete our lecture.